Friends on still. Okay, good. Thanks. And there's a clicker there. All right.
Okay, well, good afternoon, everyone. Thank you for coming back. I know it's a temptation when it's a Friday afternoon and the weekend is looming, and I'm the only thing standing between you and a Friday night. But we've got an entertaining and stimulating and informative afternoon of presentations, so I'll promise you that coming back will be worthwhile. My name is Ian Barker. I have the privilege of being an honorary professor here at Exeter, and in my day job, a friend described what I do as meddling in the UK international water sectors, and that probably sums up the sort of variety of things that I get involved with various fingers in different pies. But this afternoon, I'm here to chair this session, and we'll begin by reporting back from the workshops from this morning, 4 brief presentations, and the presenters have promised me that it'll just be 5 minutes each and not a rerun of the entire workshop. So first of all, can I call on Pete to give feedback from the session on real-time data and the need for hydraulic models? To which the answer is...
Yeah, thank you. Yeah. What was the question? So great to be back at the front for a few moments here. Can I check if I got Ulla in the room? Okay, good. So I have a big bundle of paperwork which emerged from our sessions earlier. And ultimately, what we were trying to achieve was to get to some kind of roadmap where we would have a bit of a discovery session, do some dreaming, design some kind of solution and work out what the deliverables might be. And we had 5 different tables that explored this. We got a really nice overview from Ulla Mark as to what's happening out in Denmark with some real-time data from about 100 sensors in SCADA systems, from which they're able to... In fact, we got a real-time demonstration of this for one of the cities. Unfortunately, I can't pronounce the name. Sorry about that. And then we went on and had a look at some of the more classic industry software, the InfoWorks ICM type technology, and guys like Ben Hamilton, who are working on this on a day-to-day basis, were able to kind of give us a bit more knowledge in the room around that. I then had a little bit of a reflection on some of the work that Southern Water have been doing, where they've deployed these 20,000 sewer level manhole sensors. And we keep asking the question why, and I know that they must know why. But the why is in order to get loads of data, but we're not absolutely sure if we know exactly what the problems are. So within the session, we look to try and establish more what the problems might be. So we know that with those real-time monitoring systems, you can identify blockages in real time, or in fact, proactively clear blockages as they start to come up in the pipes. You can clear them 24 hours prior to getting a call from someone that your blockage is going to cause a problem. And so that is kind of number one use case. But then each table established 2 or 3 other potential use cases. Highlights for me, building on Mohammed's inspiration this morning, one of the tables decided that perhaps we could look at gathering temperature data alongside the level data. And was thinking, if we've got this comm system in, if we've gone to the effort of opening a manhole, setting up a tripod, getting some guys out there with a sensor kit, couldn't the sensor also have a little thermometer on as well? And we could have additional data. And I think that probably unlocks all sorts of other different sensors that could go in the future on future generations of these things. Back to my scrappy notes. So that was the different sensors one. The guys from DigiLab, shout out to Mikhail, who may be in the room. Thank you, Mikhail. So the DigiLab guys had a conversation about octopi, and how octopi have intelligent arms and legs and decentralized nervous systems. And we essentially managed to walk us through to the point of having more edge intelligence in some of these systems, I think. And that sounded like a sensible idea because we had this envisagement of a control panel and a control room, which in theory is nice and calm, but is in reality completely red lights behind everyone and lots of screaming. So if the edge could do more triaging of the alarms, the better. And that, I think, was the broad point there. And yeah, Ulla gave a really nice summary. I can see Ulla now. Did you want to add anything in terms of our session? So Ulla gave us a really nice wrap up. But from my perspective, it was really interesting. And personally, the thing that I'm taking away from it is that we might only have depth at 20,000 locations in the Southern Water Sewer Network, and maybe it's 15,000 by the time you've lost some comms and other things like that. But if we can in the future have flow, then that real-time flow data is going to be killer data for hydraulic models. You'll be able to run the hydraulic models in a kind of more well-calibrated state than ever before. So this feels like the direction of travel from my perspective. And there we go. That's a summary from me. So thanks for the few minutes to come and do that.
Okay. And next, James Webber. There you are. While James is coming down, talking about novel economic mechanisms for stormwater management. Stormwater management, very topical at the moment.
Last time I apologise for sitting at the back, but I think it actually adds a bit of suspense to what I'm about to say. So I'm quite pleased about that. So we had, our workshop was more of a discussion, exploring where we thought the sort of future research directions and research questions were, trying to twin environmental economics and water engineering. We sort of spoke about the sort of main drivers for why we think this is important, particularly in stormwater management. So historically, we've spoken a lot about stormwater flooding, but at the moment, CSO policy, aging infrastructure, changes to climate, there's a lot of drivers in this space. And we are very good, particularly in engineering, at designing solutions when we know the problem very well. And we're very good at modelling systems. But there's a gap at the moment between what we can do in theory and then what we routinely get in practice. So our focus was really about how we can combine these disciplines to take some of that policy comparison focus from the economic side and then move that across so we can realise some of the benefits from what we're doing in the engineering theory sort of through proper application. We went through about 10 sort of key questions as to areas where we think either we can move quickly or sort of over more time towards twinning these disciplines. And we spoke about there are some sort of tactical applications we can make where we've got a method in engineering and we've got a sort of evaluation methodology or an application methodology in economics. They both exist and we can twin them together and therefore make quite quick progress on quite targeted areas. So things we spoke about there are things like using ecosystem services, valuation mechanisms for understanding what the sort of wider benefits of things like green infrastructure are. We also spoke about more strategic long-term visions. So thinking about how we can apply new methodologies, which have maybe worked in other areas of economics, but then add our sort of drivers and our sort of the science from our water engineering into that. So a big thing that we spoke about was how we can try and use markets, so things like a credits market for things like stormwater. So we can actually start realising different mechanisms for managing stormwater and do it in a more decentralised way. I have a list of 10, 11 areas, key questions, so I'll find a way of disseminating that, but I'm not going to read them all through now. But if anyone is interested, come and find me. So thanks very much.
Thank you, James. Next up, Razia, please. Thank you. Razia had the good sense to sit closer to the front.
Okay. Good afternoon. So our session workshop was slightly different. It was designed in a kind of interactive presentation discussion format. So we had 5 presentations and they covered from physical modeling, numerical modeling of asset health modeling, basically looking at how assets are deteriorating and developing some digital twin to make sure we have got visibility of our buried assets more. Then we had another presentation by one of the researchers looking at historical leakage, minimum night flow, and developing some prediction capability to say something about leakage in the distribution network. And he looked at around 800 DMAs and trying to develop an algorithm which can say what is the contribution of each pipe to minimum night flow, therefore contribution to the leakage. Then we had a presentation by another researcher. She looked at real-time monitoring data, flow data to develop algorithm that predicts the gradual growing leaks in a water distribution network at early stages before it peaks high volume and it is detectable by acoustic sensors or other methodology. And finally, we had another presentation looked at optimum location of pressure loggers in the distribution network to have a more spatial coverage of system and also to detect leakage in the distribution network. It was very interactive session. Thank you very much to all the participants with their very interesting questions and comments. The key message from the session was we need to collect more high quality data. We need to install more sensors. Just applying these advanced AI methodologies to any data and generating some results is not good enough. We have to challenge the quality of data, maybe contribute to standardization of the data as well. We had some contributions from different participants with different backgrounds from water companies, researchers. So it was very interesting to look at, hear about different views. But the key message was to make sure data quality is good. More data is needed to be able to be in a position to use data for decision-making process. I hope I covered all the views very well. Yeah. Thank you very much.
Thank you, Razi. And last but not least, in terms of the feedback, Albert with extended reality.
Thank you very much. So we had this workshop very useful. It's a combination of what we are doing the CWS event as the project we are working on, waterline projects, and to get the opinion from all the audience participants to learn how are we thinking about the extended reality can be used for the water research and the education. Is very intense discussion among different questions we put to our audience. So we got very good feedback. That's why you don't see many of our waterline partners there. They're using this momentum, continue the discussion in the other room now. Yes, but what I want to brief you that's what we got from here is that we try to look into what have any of participants considered using the extended realities and or what kind of technology they have used, and so they depend on the different nature of those kind of technology. So they got different variety of ideas. Why they use this particular technology, because the limitation of hardware, because the easiness to use of the software, etc. So that's how this affect the decision in order to take different technology in the application. But we are more interested about the why they don't use that, what they think about the barriers. And it seems that although this kind of quite popular, you see quite a lot of application, but if for us to adapt that application, there's still a lot of knowledge gap in terms of our own capacity to develop this kind of solutions. So we might need to learn about coding, how to turn that from the idea into some AR applications, and also we need to improve our capacity as a user interface or user experience design in order to disseminate the message we want to the users to get from this using those applications. So that's there are also some requirement, because this kind of maturity of this kind of technology, for some area they're quite mature, but for water application there's not so many applications or existing tools we can adapt easily. So they will require a huge investment, the initial investment in order to create application, in order to build a critical mass that can be accelerate the application to wider communities. So that's what we think that would be good if we can try to think how are we going to standardize this and to create some kind of repository that can allow the user to share the application in order to some others can easily to adapt and in order to turn this to the different application more easily. So hopefully it will becoming some sort of Lego. So that's we just all these things become just Lego bricks. And what remaining for the user to use an application for the water research education is their creativity. How they want to use the Lego to build some application that will help them to demonstrate the particular challenge they want to resolve, they want to help the student to learn, and they want to train the engineers. So that's what we want to achieve at the end goals. We want to build this capacity, bringing different knowledges together, and through this exercise, we hopefully we can provide some guidance or kind of documents that allow the template. Should be the template the other people can follow and in order to adapt. And so we will try to create this kind of ecosystem like what we have this Android app or Apple apps that can easily be used to adapt for wider application, and that will enhance our learning in the water education and the research. Thank you.
Thank you, Albert, and thank you to all four rapporteurs for responding so succinctly. The title of this session is the way forward, and listening to those four, there's so much potential in terms of what was covered in those workshops. We might want to reflect on that. We've got time later on this afternoon for an open discussion. So if the things that particularly resonated with you in terms of what you've just heard, that you think this is what CWS should be thinking about for the next 25 years, then just put that at the back of your mind and we'll pick it up later during that open discussion. But now we'll move on to 5 speakers talking about some of their particular research. And first up, I'm delighted to welcome Ridi Hossain, talking about community-centric rainwater management. Okay, Ridi.
Hello, my name is Ridi. I'm a PhD student at the Centre for Water System, and I'm also working with Southern Water. And we are looking, one of the case studies I've been working on is looking at slowing the flow at source and monitoring rain barrels on the Isle of Wight. So first, I'll take you through the introduction. So background to the study on Isle of Wight, and then we'll address the aims. So addressing the primary goals for leaky rain barrel monitoring. Then we'll go through the method, so the case study location, and we'll have a look at the area that was managed. And then we'll go through the methodology, so the methodology used for monitoring leaky rainwater barrels. And then finally, we'll look at some interesting charts of rainfall intensities versus combined sewer spills. And then finally, we'll conclude with summary of key findings and some next steps. So rainwater from impermeable surfaces can often get contaminated by surface contaminants and then routed to the combined sewer system, which can cause these sewers to get overwhelmed. Combined storm overflows have been introduced as a solution to the problem. CSOs act as a relief valve for the drainage systems to prevent sewer flooding of properties and infrastructure. However, their usage has been increasingly unacceptable to the public owing to concerns about pollution. To address this growing dissatisfaction, Southern Water has implemented a storm overflow task force to address the issue of combined sewer overflows in catchment areas, including Haven Street. Slow drain rain barrels were installed in 142 houses, which had a strong uptake of 70% to reduce the occurrence of overflow spills. Each rain barrel has a capacity of 200 litres, which was manually installed in the autumn of 2022, where they put in a 4mm diameter hole approximately halfway up the rain barrel. We used data from June 2020 to November 2022 to monitor the effectiveness of this nature-based solution through the interrogation of rain gauges and storm overflow spill data. So the aim of the study are as follows: to model the effectiveness of the rain barrel installed in the 142 houses in Haven Street. We did this by using data manipulation techniques and data science and relational data modeling to establish a pattern between overflow spill reduction and high-intensity storms. We used another aim was using rain gauge and stormwater overflow data to compare spill volume for similar intensity rainfall storms before and after the inventions. We did this using a combined graph format to present the data and compare the performance before and after the implementations of the rain barrels. So this is the case study location. All the red and yellow roofs highlighted have a slow drain rain barrel installed, and after intervention data was collected from August 2022 till November 2022. So the following methodology was used to develop the study. We looked at the intensities of the rainfall and how that affects the spill. We manipulated the rainfall data, which was originally provided at 15-minute rainfall intervals, to calculate the intensities of the rainfall, which was measured in 15, 30, 45, and 60-minute increments. Spill data was downloaded, which were the data of the spill, and we made it into a binary format, into zeros and ones, from yeses and nos, to present in the graph. And we plotted rainfall against dates, showing the different rainfall intensities, including when there were spills. So this is the initial chart. Here are the results that were generated from monitoring the rain barrels. From rain barrels and using rainwater data to understand how well the rain barrels are working. Here, Figure 1 shows Haven Street intensity. Haven Street in rainfall intensity graph, showing spills with a red dotted vertical line showing rain barrel interventions. The plot represents a series of different rainfall intensities, 15, 30, 45, and 60-minute intervals from June 2020 to November 2022. The red dots indicate whenever there was a spill and typically coincide with a high-intensity rainfall. Overall, from the analysis, we can see that prior to intervention, wherever there was a spike in all rainfall intensities, there was a spill. Specifically, the results in the graph seem to suggest that rainfall intensity has a stronger correlation with overflow occurrence when measured at 15-minute intervals. And if we break this graph into and extract the 15-minute and 60-minute graph, this is what it looks like. And looking at the separate charts for the 15-minute intensity metric in Figure 2 and 60-minute intensity metric in Figure 3, the 15-minute intensities correspond with the overflow spilling, while some spills do not correspond with the 60-minute intensity spikes at all. This further emphasizes that the overflow spilling was due to the results of short, intense 15-minute rainfall events. And we can see from the results that there have not been any spills for a rainstorm in August of 2022, whereas there was a series of spills for a similar storm in the summer of 2021. Moreover, from looking at all the recent storms between September and mid-November 2022, there have not been any spills since the rain barrels were installed for that period of time. Conclusion. So the data seems to suggest that the rain barrels installed in Haven Street has been successful momentarily in reducing overflow spilling. However, further research and data analysis is needed to guarantee the success of the rain barrels as a potential solution, and we need to monitor how well it's going to work over time. The leaky rain barrels are a cheap and accessible solution alternative compared to other solutions. Additionally, the residents of Haven Street have accepted the rain barrels and have shown promise not to remove them, ensuring the barrels will remain effective in larger storms in the future. Overall, next steps include monitoring how well the rain barrels are doing currently. Currently, it has stopped working for a period of time, and Southern Water, and we are looking into what changes we can make to these rain barrels, and going back and talking to the individual owners, and then hopefully by next year I'll have more updated results on this case study. Thank you so much for listening to me.
Thank you, Ridi. That was great. We've time for some questions about what's a really important project, because Southern Water struggle with CSOs like many companies, but Southern Water seem to get it in the neck more from the public and regulators than perhaps some other companies. So any questions for Ridi? Dave?
Thanks, really good. Do you have any information on the extent of the water barrels relative to the CSO? How important were those streets and the spills?
Do you mean how much impermeable surfaces were?
No, I mean, when you say spill,
Yeah.
do you mean a CSO or do you mean
yeah.
out of the butt itself?
The CSO spilling.
Yes.
Yeah.
But to what extent, how important are the barrels in that catchment?
It's very important because essentially we are, as the name suggests, is slowing the flow at source. So we are trying to essentially slow, with all these houses, 142 houses, and all these rain barrels, we're trying to slow down if the water leaking into the area. So
it would be good to work out how influential they were. How much?
Oh yeah, definitely.
Very good.
Yeah, it's the data we're looking into still. But yeah, thank you.
Yeah, thanks, David. I know you have sharp.
Very impressive. If you turn the graph with the results, please, you have a period from the February when you had the last spills to August or beginning of July, where you don't have spills, but you have spikes in rainfall. The question is, spatial distribution of rainfall can be very important. And where did you measure the rainfall?
So we didn't really take I believe we had rain gauges within Haven Street, and so it was just around that area. We just I believe we had one rain gauge. Pete. Yeah, I'm not quite sure exactly where we got the data from, but
yeah, I think in this study there is just one rain gauge nearby, and I think just one of the observations that might follow on from here. So we've got in some other studies. So Ridi's study is looking specifically at 3 or 4 different case study catchments, and she doesn't have control over the kind of setup. So we get the data at the end of it. But what we've observed in some other studies is that these winter periods, there can be infiltration, and that can be an influencing factor. So at the moment, this right-hand side where it appears that there's good impact from these rain barrels could be at the end of a year when you've got reasonably low groundwater levels. And then as we enter into the winter, then we might have a higher groundwater level and there might be less benefit. But so, sorry, that doesn't particularly answer the question. I think it's driven off one rain gauge in this catchment. In some other studies, I know the Blue Heart folks are here, there's talk of installing about 15 rain gauges across the city, and that will be a location where we'll have some more kind of good detailed rain gauge data.
Yeah, in this project, we only have one rain gauge, but another location where I'm looking at in Kent, we have multiple rain gauges upstream, downstream, and different roads, which gives a more detailed analysis on, especially within the locality. So, yeah, thank you.
Hi, this is Fayaz. I'm sure you have got this in mind as well. The level of fullness of the barrel itself, of the usage of the during dry period, was any water usage from the barrel or something? This is something you will be monitoring or what?
Monitoring water usage by the owners of the rain barrels?
Yes.
So currently, when we implemented them, I believe we expected them to use the rainwater it was a partnership that we get to install the rainwater barrels within the property, and the owners get to have the rainwater for their own usage. But currently we've found that after a while, it's been a while since we've done this, some owners haven't been using them as much, so the rain barrels haven't been as effective as they could have been. Now we are looking into going back and talking to these owners and how it could be more beneficial for them. Perhaps a behavioral scientist could talk to them and why this is useful. So we are looking into that, and perhaps I should probably feed back to Southern Water that we should look into monitoring this as a way of maintenance for the rainwater barrels.
Yeah, and I think that's really important, because if Southern Water want to roll this out at scale, then that'll help with the cost-benefit case if it's also helping with demand reduction as well. So, well, thank you very much, Ridi. That was an excellent presentation. And great questions. Right, second presentation now. We're doing nicely for time, so thank you all. Is Jess Holland. There's Jess. There you are. Thank you. Predictive maintenance of wastewater systems using machine learning. Jess and I had a conversation earlier, and she's doing some really interesting and important work, I think.
Thank you. How do I use this? Sorry. Thank you. Hi everyone. My name is Jess Holland. This is essentially my PhD title, my question title, Predictive Maintenance and Wastewater Treatment Using Machine Learning. And I'm going to be doing a bit of an overview of the topic. I'm in my second year of my PhD, coming towards the end of my second year, for context. So I'll start off with a brief overview of kind of the topics at hand, just as a refresher. So machine learning, broadly, just where you're using a model to learn from data and to update its ability to predict things from some input to some output. Most kinds of machine learning fall into these categories. Not all of them, but the commonly used ones are regression, where you have a continuous input going into continuous output. So, for example, in the use of maintenance, this could potentially be something along the lines of estimating the remaining useful lifetime, so years or days, or even something like calculating energy consumption. We also have classification, which is a discrete output, so that's a discrete class, A, B, C. It could be something like distinguishing between specific faults, so this is a bearing failure, this is a gearbox failure, yes or no, will an asset fail within this sort of time window? And then we have anomaly detection, which is again kind of fairly self-explanatory. It detects anything that's outside of a normal range which you have defined. So this could be useful in maintenance for giving the model just standard operating data. You don't have to define what failures are, but it will be able to, if it works, predict when something is happening outside of that range. Then you might need to go and have a look at the equipment you're monitoring and maybe just assess for further faults in more detail. So how can maintenance be conducted? What are the different regimes we can use? Broadly, again, they kind of split down into these categories. I'll mention briefly that with predictive maintenance, there is sometimes differences in the terms people use. You might hear proactive maintenance for predictive maintenance. Also, I've sometimes heard that for planned maintenance. Condition-based monitoring is another thing. They kind of overlap, but they're generally self-explanatory. Anyway, reactive is literally just acting after something has failed. So you wait for an asset to break and then go send out people to fix it. It can obviously be expensive. It ends up with downtime that you might not want, you might not have planned. That can have capacity issues. That can make it more expensive to kind of then mitigate the problems. So tankering, sewage from different sites and having emergency overnight call-outs for maintenance, which can obviously be a problem. We have planned maintenance, which is another commonly used one, just on a time-based schedule, essentially. It can be too frequent or it can be too infrequent. You try and catch them before they fail, but that also might be a waste of money sometimes. So pros and cons to each one. And then predictive maintenance, which is what I'm looking at, would seem to be a good option. It is acting based on the actual machine condition and trying to predict failures before they happen so that you can send out appropriate maintenance and not waste time servicing something that's working, but also not wait for something to break and have to deal with the downtime. And it can also provide other insights into machine operation, such as, again, like broader asset health, how it's operating. Could you optimize its operation? Could you look at its energy usage, that kind of thing? But I will say it is important to remember that that planned and reactive maintenance also have a good place in the system. It's not always appropriate to use a really fancy, expensive system. There's certain things that are just good to have a run to run to failure regime because maybe they're very easy to replace. So it's really important to find the right tool for the right situation and not just throw everything into the innovations, which I know is what I would like to do otherwise. So are your utilities actually using predictive maintenance? The short answer is they are beginning to. There are sort of quite a few news articles in the past 5 or so years showing that water companies have started to put out like invitations to tender. They started to award contracts and run trials or announce partnerships with all these different condition-based monitoring or sensoring or maintenance companies. And this is the best I could kind of try and show what's currently out there. It's a bit confusing, but I'll run through it. So just from what's publicly available, it would seem like Anglian Water are quite far ahead of the game. They have just recently, in April, they announced a partnership with 5 different condition monitoring companies. They've already got an existing one as well with 8 Power. And they've also got something called the Shop Window Catchment Project, which is a geographical area they use to trial lots of new innovations. And it's not necessarily all condition monitoring, but it kind of shows that they've really got like that drive for innovation and they're putting a lot of thought into this kind of thing. Then I will run quickly through some other sort of highlights. A supplier that is used a lot is Semotics. They do something called electrical signature analysis. It goes in the motor control cabinet and it's sort of monitoring something that's slightly remote from the asset. They seem to be working with a lot of different utilities. They work with the 4 I've mentioned here and potentially kind of are expanding as well to others and trying to get trials going. They've got a lot of benefits, as I said. It's ease of installation because the sensors are remote to the assets. They don't have to be submerged or in a hazardous area with gases. You don't have to worry about ATEX as such, as something that's like submerged in a borehole pump. So they have a lot of benefits going for them. And there's other companies as well that have sensors. So that's like different vibration monitoring sensors. There's one called shock pulse monitoring. Semotics also provide the service of AI analysis and just like an ongoing support towards companies. They generate email alerts, which means that the water companies don't have to actually do the analysis themselves. They just have to check the emails and go and respond when something's flagged up as being potentially anomalous or a fault. And this is the second part of what I've been talking about is slightly related to another company, A System, who again just collect data from multiple sensors and provide an AI analysis. But then you've also got a different approach, which is what Wastewater is using. I've forgotten to go through these. Wastewater have done something slightly different where they've used ADX, which is an analytics platform, and it just gathers all their existing data. So they're not actually putting any more sensors out. They're not having to go and install things. They're using all the current data they've already got from SCADA, for example, and that means that they can just see it all in one place. It's a lot easier to work with all the huge amount of information they actually have, but they often don't know what to do with. So this is another approach where it allows them to then do the analysis in-house and not have to go through external contractors, which could have its own sort of difficulties. So there's a variety of approaches that they could take here. So then I'm kind of moving now on to what I'm looking at a bit more in my research. On the technology side, I'm looking into machine learning using the input of audio. It makes sense intuitively that audio could be used for monitoring conditions of machines, because if you've ever driven a car or had something in your kitchen that sounds weird, you'll think that I need to look at that. I might have to turn that off and look at it properly, take it to the garage. So it does seem to be the case that you could do something with this. And that's kind of what I've been looking into. It's in the literature. We've got examples of it being used in other industries, such as in manufacturing and machining, things like this. There's something called DCASE, which is the detection and classification of acoustic scenes and events. It's a community that run challenges every year. And in 2020, they did a challenge specifically on this topic, detection of anomalous sounds for machine condition monitoring, using a couple of data sets that I've mentioned here that I'm going to also be using, that these are freely available and used in a lot of literature for machine condition monitoring. Audio also has like a few benefits. It's similar to the to technology used by Semotics that I mentioned earlier, where it's somewhat remote from the asset itself. Like microphone can be situated a few meters away, which can be quite a big difference in terms of the considerations you have to make. You also have different faults potentially having different audio profiles. So using machine learning, you have potential to be able to detect anomaly, but also potentially to be able to detect what the specific fault is, and maybe even detect multiple faults at the same time that could be overlapping. I've not been able to find any examples of audio being used in the water industry for this purpose, but there is the will from the water companies, in my opinion, from what I found, and a good opportunity to try and implement this sort of thing. I've been doing another study that is my poster you may have seen outside, where I've been talking to water companies about sort of their wants and their opinions on this kind of thing, and I think it seems like it could be a good place to look. So something else I'm looking into specifically is how water itself could be used as an input, like the sound of the water itself. That's something that's different to other industries such as manufacturing. Water companies have water going through all the machines they're using, so can we potentially use something? Is there something in that we could use for analysis? So the experiments I'm running, there's a couple. It's using just the lab we have on campus at the moment with hydraulic benches and flumes, and I'm trying to see whether I can use recordings of the water to try and predict things like features of the flow, such as the flow rate, for example. So I've tried one so far, just using a lapel microphone, varying the flow rate, seeing if I can find any patterns in this using Python, using Fourier transforms, wavelet transforms, and I'm going to be trying to put it into machine learning, into a model. I'm still working on that, and I've had some difficulties with the precision available in the machines, in the equipment we have, so I'm not sure if I'll be able to use it on machine learning yet, but I can definitely look and see if there's any patterns that you can just trend with your own eye. In a couple of different interactions, so like fluid onto free surfaces and onto solids and submerged. And then another experiment I've got planned kind of based on the learnings from this half-done experiment is I'm going to try and look at blockages and obstructions in the flow using the medium-sized flume that we have here on campus. So I'm going to try using a hydrophone rather than an air microphone, which can then reduce the amount of other room noise and pump noise, so I can put it closer to where the activity is actually happening. I'm going to try using different kind of shapes and percentages of blockages in the flow, like with a sluice gate apparatus, which could, the idea is that it kind of could simulate the actual use case of inlet screens in wastewater treatment. So they get blocked up a lot. There's also other blockages, other parts of the flow. So that's what I'm trying to investigate next, trying to kind of learn from my previous experiment. The idea is that this could be really powerful in conjunction with the existing machine condition monitoring using audio. So I could potentially try and look at the audio of the actual machine itself and of the water going through, and maybe we can get some advanced insights from that, hopefully. Broadly, I'll just summarise kind of what else is going on in the future. I mentioned my 100 conversation study, so this is what's summarised on my poster outside. I've been talking to the water companies, trying to get a representative or a couple of people from each one and talk about the barriers and opportunities they think there are for condition-based monitoring and predictive maintenance. Generally, it's positive, as in there is definitely an interest for this. Almost every water company has responded saying that they would really like to become more proactive and less reactive, and I kind of have a better idea now of what the challenges might be towards that. I've also found out there's a condition monitoring working group within the water industry, which is perfect for knowledge sharing. It's representatives from each water company going along with supplier showcases each month, and it's very helpful for just them sharing knowledge amongst it themselves, because that's something they've struggled with, according to them, understanding what is out there. There's a project which I know some people in the room are involved in, the Artificial Intelligence of Things project, which is sort of looking at, it's kind of running in parallel to this kind of thing. It's with the University of Exeter and a few different water companies and condition-based monitoring suppliers. This is something that Ofwat's funded, so it shows kind of the industry interest in going into this kind of field and advancing and improving technology to become more intelligent with wastewater networks and with actuation and with optimization. And it potentially kind of touches on like maintenance as well. And broadly, everyone here, even people outside the room, I think would know about the coverage of sewage spills that's been happening in the media. Definitely a change in public interest in this kind of topic, and it seems as if this should have an impact on what the water companies are doing as well and what the regulators are doing. You would think that this would affect their plans for maintenance and to improve the way they operate, to avoid this kind of this damage, this pollution, and coverage of it as well. So broadly, it looks like there's an opportunity to move into this area and to use the technology that is out there and that we know has a good sort of grounding, good basis. It's been established in other industries. you would hope this is a good opportunity to use it and really see some benefits. So yeah, thank you very much for coming along.
Thank you very much, Jess. We have, again, time for some questions. Because it's a subject close to my heart. Water companies have been criticised by regulators for what's called sweating the assets. In other words, cutting back on maintenance in a misguided attempt to make some efficiencies, and then getting blamed when, not surprisingly, their bits of kit fail. So I think there'll be a great interest in this. But if they're going to make a bid for more money for maintenance, they'll need some understanding of the sort of level of confidence that might apply through more predictive maintenance approach. Do you have any feel, Jess, for what sort of level of confidence these techniques might provide?
So as a first step, it's definitely going to be easier to do anomaly detection where it's just there is something going wrong, we don't know what it is, but that should be fairly doable. I think that would be implementable. When it comes to like specific fault classification, like identifying what the problem is and how it needs to be solved, that might be more of a challenge. But there's been some good successes with existing condition monitoring technology in some of the water companies. But it is true that there is a worry potentially. There's something that did come up in a couple of the interviews, is that it's about putting trust in something that for many people might be a bit unknown and a bit scary. And if it doesn't work, because it's not going to work all the time, there's going to be times where it doesn't catch a failure, even if it's really good, that could put it back in terms of adoption and the sort of in terms of like the resistance to changing to something new. But yeah, I think we can manage with all the different kind of technologies we've got, because each different inputs, like different kinds of sensing, can be good for different assets. I think if we kind of use them all on the right thing, we can definitely be able to pick up a lot of the changes. And if we have that in conjunction with other data sources too, so we can validate that against is it at Storm at the moment, that will make it a lot more reliable, because then it's not just looking at one data point, it's looking at the whole network. Yeah. So that would make it a lot better.
Dragon.
I just sounds very interesting to look for sound or vibration, and in the drinking water sector, that is now being looked upon as the only technology. I think they are going to detect leakage as an anomaly in the behavior of the system. But you're looking at assets and sewer assets where you have free flow that is highly variable. Am I correct?
Yeah, I'm mostly looking at, I'm sort of focusing on wastewater treatment plants and the assets in that.
Okay, yeah. Sorry, I misunderstood
no, that's okay.
that.
But it might also be applicable in other areas.
Okay, and then just to understand your approach, so you're talking about permanent installation of sensors that will collect sound information, and then based on changes, you will assess the useful life or a situation where something needs to be replaced. Yeah, sorry, I was thinking about CSOs and networks and everything else. Not
Thanks, I'll clarify next time.
Okay, great. Well, thank you, Jess. Next, welcome to Barry Evans, talking about simulation-based management of flood impacts on transportation systems.
Good afternoon, everyone. My name is Barry. I'm a researcher here at the Centre for Water Systems. Firstly, thank you for giving me the opportunity to talk about my research today. This work wouldn't be possible if it wasn't for the research done previously by a former PhD student at the university, Katya Petkova. I hope I pronounced that correctly. She looked at the impacts of flooding on transportation networks. And I've been fortunate to be involved in this work following on in the research. So this is part of the work I'm doing on a project called Asinoi. where I'm looking at assessing the impacts of flood events on traffic, and particularly like vehicle flows. And it's quite a complex like impact assessment to carry out because you've got a dynamic flood event, both like it's changing, the conditions are changing over time, but you've also got dynamic traffic conditions, and depending on the time of day when the flooding occurs, it can have a greater impact. So flooding at a rush hour could have a greater impact than flooding at, say, like 1 in the morning. So for this, we wanted to create like flood event traffic profiles, which we could then use as a prelude to our other assessments, looking at like first response and mitigation strategies. So just a little bit of background about the software we're using. I'm using this open source software called Sumo. It's multi-scale traffic modeling software, and it's multimodal. So we can do like vehicle modeling and pedestrian modeling. We can do different vehicle types. We can even change the parameters of the actual pedestrians themselves to give them different walking speeds. We can import data from OpenStreetMap, which means, again, our data sources can be freely available. And the open like StreetMap community are very active. So we've got very detailed data sets. So, and I forgot the latest point on here, but we can get like traffic light information for the network, sidewalk information, car parks, buildings. So we can start building up a nice, accurate depiction of the network itself. And there's also a lot of people in the community like working on tools and supporting the software. So one of our case study we're looking at in the UK, we're looking at the area of Tor Bay, but to make the modeling simpler, we've broken up into a few regions. So this is the region I've been trialing the software on at the moment, so looking at Brixham. And I'm looking at a historical flood event which occurred in August 2020. And this is I'm pointing the mouse the laser at the screen. This is the hyetograph that we're looking at here. So it's like I think it might be a 1 in 20 year event, but I'm not too sure. So in terms of building the traffic model itself, we need to create a baseline traffic model and then flood the network to see what the impact is. And there's different ways of doing this where we can create like an origin destination matrix based on where people live and where they work and schools, etc. Or if data is available, we can use traffic count data. So on here, I've got average daily traffic flows for the area. But of course, this is an average count over a 24-hour period. And we want to try to capture the effects of like rush hour in traffic. So using alternative data sources relating to traffic flows within cities, I can redistribute this average daily traffic over a 24-hour period to create these sort of like morning rush hour and evening rush hour scenarios. And this gives us our like sort of baseline model. To integrate this sort of data into Sumo, one of the tools that's available is this tool here called Route Sampler. And what we can do is we can map the traffic counts over time to different road sections. And we can generate a random routes catalog, which is 10,000 random routes generated for the area. And I do a little bit of cleaning on this data just to make sure the routes are plausible. So no U-turns mid-journey, no one's really doubling back on themselves. And then using the route sampler script, we can try and find an optimum solution to match the traffic counts for different times of day. So mapping the counts I've got for Brixham, I get, like I said, about 11,000 car journeys in the area which I'm looking at. And this just shows the number of vehicles on the road at any given time of day. And we see our morning rush hour and our sort of like evening rush hour. Now, of course, we're building this depiction based on our random routes catalog. And if you generate random routes again and then run the traffic counts, it may find a different solution. So what I've done is I've just created like an ensemble of solutions which give me like plausible traffic flows for the region. And then I just do a quick visual comparison at the moment against traffic at different times using Google Maps, just to see if the traffic flows align with what's been depicted in reality. So this just gives an example of our different scenarios to generate our, in this instance, like 10 different route files. And this here, which we'll show some more this sort of diagram later. These are our 10 random traffic scenarios, or well, route scenarios that we've generated. This is the time of day, and then this like the z-axis here. This is our peak traffic flow. So we can see we get some differences for each scenario, but they are close approximations to what we see in the traffic count data. So when we're linking this with, while we're looking to link like flood modeling with traffic modeling, is if we just look at the hazard assessment, we can see where the flooding is occurring on the roads. But the disruption to traffic is not isolated just because of traffic can't move along, say, from like E to H. In this instance here, if the roads are closed, the red vehicles could divert along this route here and then go down to its destination point. But these traffic flows will disrupt the flow of traffic along here, so increase congestion. Alternatively, the traffic could choose this route and increase congestion here. And in Sumo, we can look at these solutions. We can look at like what would be the shortest path, what would be the most optimum path based on current conditions. We can also give like knowledge to the driver. So in instance here, this driver could see that this route is closed, and he may think to go this way, but when he gets to this point, he sees this route is closed and goes up. So this path might not be the optimum choice; it could be this one. So Sumo gives us an idea to play with these scenarios. So I'm going to take a risk and just show a video if this works. So this is just a simple demonstration of linking the flood model to the traffic model. So this is, say, an example network. We'll have cars coming in from the right, go from right to left, which should come in shortly. You see the count going up. Okay, so this is like shallow flood water. Cars into the water. You can see the brake lights coming on. They're slowing down. The water will get deep, and the cars will get stuck. Now, cars approaching will turn. They're aware of the stuck. They turn green and they reroute accordingly. The water subsides, and the cars then continue on with their journey. So this is kind of what we're trying to capture in our like coupled model. So as I say, we're looking at traffic, which is like the occupancy of cars on the roads are varying over time. So we've got our rush hours, and for this particular modeled event, we've got this is kilometers of roads flooded. And we can see we've got these two peaks that coincide over a 5-hour duration for this particular event. So we wanted to see what the effect of this event would be on traffic flows if it occurred at different times of day. So this just gives a sample of the routes here. So this is our flooding here, and then I've just overlaid the event here just so you can see like we've got like a peak depth here and a peak depth here. So if the flood event occurred at midnight, this red window here represents the duration of the event. And we can see that it has like almost like negligible effect on the traffic flows. As we start creeping forward, so it's starting about 2 in the morning, we can start to see some discoloration here, which means we're starting to get like a increased like bottlenecking of traffic. And then here, so the start of the flood event will be at 3 in the morning, but we're catching this second peak at about around about between 8 and 9. And we can see here now we're starting to see like significant disruption to the traffic flows. Then we're looking at the afternoon sort of traffic flows here, and we can see that at 8 in the morning. We're getting significant disruption here, where we're starting to affect the number of vehicles that are increasing around about 1 o'clock in the afternoon for this scenario. But we can see across all these sort of scenarios here that we're testing. When the second peak of the flooding coincides with about 4 p.m., we start to see significant disruption to traffic flows like post-event. So what I did finally was to create sort of like a profile. Is I just took like the average of each of the scenarios to look at the disruption, just to identify where the maximum disruption to traffic flows would occur, and then based on this, we can start looking at the sort of like next steps. So, for instance, when we're looking at first responders, we want to see how long it takes for a first responder to go, say, from the hospital to different parts of the city. And we can model it now whereby at different times of day, so about running this flood event, we can see about how long it takes for the first responder to reach different regions. Additionally, we can start looking at what sort of, if we look at the impact spatially from the SUMO model, we can look at where we can target our mitigation strategies to see about rerouting traffic to try to bring this disruption down. And so this is the beginning part of what we're looking at in Hossain, but I'm happy to take any questions. Thank you.
Thank you, Barry. I mean, too often one sees people caught in floodwater because they think they can drive through it and then realise that they can't. But any questions for Barry?
Have you, excellent presentation, thank you, Barry. Have you accounted for the total hours delay because of the flooding in any of the scenarios? Because that, I guess, can be translated into economic loss. Have you considered that?
Yeah, so we are in the model. We can look at we look at the recovery time to see how many hours are lost by people that are stuck in traffic, and we can start estimating like monetary losses based on that. In rescue, we also looked at the potential increases of pollution due to lots of cars idling. And more recently, separate to this sort of research, using work from Wastewater, looking at the stability functions of vehicles and pedestrians, we look at the instance where, as you mentioned, people getting stuck in floodwater, and what are the potential risks to those individuals as well. So we're looking at different aspects and linking it dynamically with the model. But monetary losses is definitely one of the key factors which we're looking into as part of our impact assessment.
Barry has not had time to talk about everything he's been doing with this methodology, but for the benefit of Cobus, where is Cobus? Oh, he's gone. Okay, for the benefit for anyone who might be going to New Zealand, would you like to say a few words about how traffic modeling can help with tsunamis?
Yes, so for a couple of case studies in New Zealand, for Wellington and Napier City, we've been looking at mass evacuation from a tsunami scenario. And in particular, we want to show that under these sort of extreme conditions, it is not beneficial to get everyone to go into their vehicles and try to drive to safety. The network doesn't have the capacity for it. You actually get increased survival rates if people start going by foot. So we're looking at like a more targeted sort of assessment, looking at multimodal. So both looking at people going by vehicle, by car, looking at different age demographics to see about how we can optimize survival rates. And for areas where people, it's almost impossible for them to reach safety, we can look at implementation of vertical evacuation structures. So places midway where people can still get to and find some sort of safety. So these are what we're looking into in New Zealand.
Well, thank you, Barry. I think that's advice that we probably hope we'll never have to use, but it might be worthwhile. Thank you very much. In case you're wondering, the advice here is that 30 centimetres of water is enough to float your car away and you with it. So it's not worth even attempting to drive through floodwater. Next up is Kate Baker. Welcome, Kate. Talking about community engagement in the water sector. And when we're busy talking about water, we sometimes forget why we do all this. And actually, it's to provide water supply and sanitation to people. So communities are just quite important.
Great. Hello, everybody. I realised when I chaired the session this morning, I didn't actually introduce myself. So I'm Kate Baker. I'm a senior research fellow here in the Centre for Water Systems. So I joined the Centre in 2017, working with David Butler, and it's wonderful to see Sarah Ward in the audience as well, who I work very closely with on the Safe and Shore project. And so my background is actually freshwater ecology, and at the end of my PhD, I wanted to gain some experience in industry engagement. And so the Safe and Shore project that was working very closely with the water sector was a great place to start. It was a 1-year contract, and I'm still here, 7 years on. But my interests have developed, and my sort of interest in industry engagement has now come into community engagement. So I've only got 10 minutes. I work on multiple projects. I work on multiple EU-funded projects with Albert, Lydia, Slobodin, and many others in the room. But today I'm just going to focus in on one of the projects, which is a DEFRA-funded project, where I'm leading the engagement and comms. And this is quite a wonderful project because it merges two bits of my world. So although I'm at the University of Exeter in the Centre for Water Systems, I'm also director of a public engagement charity called Agile Rabbit. And Agile Rabbit is involved in Blue Heart, and it's a kind of the creative arm. We work with lots of artists and musicians to engage with communities around flooding. So as you can see up here, so the project is investigating how rain, river and wastewater move through Eastbourne and Southern Wealden to help reduce the impact of flooding. There are other researchers in the room who are leading on the smart technology to monitor water in real time. So that's Pete, who's a PI, and we've got Chris and Farzan. And then I'm working on the communities aspect. For those of you who are not sure where Eastbourne is, I've added a map as a true geographer, so you can see where Eastbourne is. And this is a picture showing the beautiful town, and there are people from East Sussex County Council at the back, a little wave there, who know this area very well. Okay, so if you've seen me present before, you would have seen this slide, but I always like to flash it up just to make sure we're all on the same page of when I'm talking about community engagement. So this slide comes from the Centre for Scientific Collaboration and Community Engagement, which is an organisation in the US. I did a fellowship with them a few years ago. And you can see on one side over here, we've got the convey, consume. And what's really nice, I wonder if I can get this to work. Oh, I can. So what's really nice in this is you have a slogan. So at the moment, this is sort of comms, and I'm telling you, here's something interesting. So common sort of activities would be reading, watching. So this is a really good example. I'm giving you a presentation. The organisation is the expert. I'm telling you something, and it's one person to many people. And then if you go across, we then get to this bit here, which is the co-create bit. And you'll see the slogan has changed quite a lot. Instead of the slogan, which is here's something, it's what should we do next? It's asking a question. And the power balance has changed. You'll see we're talking about mutual sharing and learning and nearing equity. That's quite a tricky one to properly do, but and it's all about sort of creating something new together. And so when I talk about engagement and co-creation, it means you've got to go into a community without all the answers. And what I'm sort of realizing is that engineers and, within the utility sector, with the Environment Agency, there's been a history and what we've heard over the past couple of days of really good sort of industry engagement. and that kind of co-creation, but finding it a little bit more tricky with the community engagement. And I've been talking with local councils and the Environment Agency around the fears of the early engagement. And these are a few quotes. I'm going to read them out to you. So the first one is, if we include residents, it will slow everything down. It will prevent us from doing what we actually want to do. What do they know? The second quote is, I did wonder if we were going in a little early before we had much of an idea of where the project was going. And then the third one is, they don't want to go to communities until they have a solution, because we have this complex that we've got to save everybody. And that last quote, it kind of shows that that fear of engagement is not because people really don't want to do it, but more that the Environment Agency, water companies, even engineering departments, they've traditionally been very technocratic, and it's only so in the UK. This is a UK-based project. In the UK, it's only in sort of 2007 when the Pitt report came out, and there's this sort of realization that if we are going to become resilient, especially with the climate crisis, communities have to be involved in that. And so with the Blue Heart project, it's as I said, a DEFRA-funded project, and it goes all the way through to 2027, which is a really nice chunk of time so you can properly do engagement, because often research projects are quite short and it's hard to actually do the co-creation and do that listening. And so in the Blue Heart project, we're using this framework called asset-based community development. I don't have time to go through all of the sort of sections, and we're still quite at the beginning of the project, but the first step is this early engagement. The first step is going out and finding the assets in the community. And when I talk about assets in this context, I'm talking about, key organizations. I often use the word keystone species because of my ecological background, but it's those people in the community who seem to be involved in absolutely everything and know everything. They are your allies. But when assets are also include community centres or places where people hang out. And so with the Blue Heart project, in order for us to create the engagement strategy, it was just key that we have these conversations and we do some listening. And we did this during the kind of tail end of COVID, although COVID is still very present. And so we use a method of community radio. And we went out with 2 radio practitioners, and we went to community gardens, we went to people's back gardens, we went to community centres, swimming pools, and had conversations about what do they know about flooding? Like, have you experienced flooding? What happens? What does it look like? And what do you care about in your community? And we also spoke to some of the project partners as well. Within the Blue Heart project, mentioned East Sussex County Council, but the Environment Agency are also involved. We've got water companies and obviously researchers at the university. So the next slide, hopefully, I'm going to play you a short clip from the radio.
And it's very quickly playing over here. So it's not like it's seeping away quickly. There's this little barrier.
Yeah, so that's the other side.
It's the weird thing about this area. It's a very much a wetland back here, but it can also get very dry.
Yeah, so it's one extreme or the other, isn't it?
We do have some quite severe droughts now during the summer. Watering young plants here, we do run out of water. Quite a challenge now to grow food in a way that's sustainable.
Water management rather than flood defence, I think, is the important thing.
So in 1995, the flood attenuation lakes were constructed, which are referred to as the Green Heart in some project papers about the area. So the Eastbourne Park lakes. We're also looking at the much wider area, so the catchment itself. So the Blue Heart project is seeking to bring the Green Heart more into the 21st century.
Okay, so that just gives you a clip of some of the shows. And these were shared once we went round and collected these stories. We shared them on the local radio. They went on our website, on social media. And also they've been shared in Blue Heart project meetings. And that's sort of a similar scenario to this, where communities, aren't involved in the organisation of the meeting. They haven't been invited, but it can be quite powerful hearing the community's voice. And it's enabled us to involve quite diverse participants, because we're going out to people. Often engagement that's conducted is either, like a survey that you have to fill out, or perhaps there'll be something in a village hall that you've got to go to. So because we did this mapping exercise and we went to people, it enabled us to get more sort of diverse people involved. It helped people to hear one another. And that benefited, the community members to hear one another, but also people from within the different agencies that were involved in the Blue Heart project. And ultimately, it enabled us to create an engagement strategy that is aligned with the community, and it actually helped shape the project. So now more money has been ring fenced for biodiversity. As you heard on there, sort of drought is also a problem. Pete alluded to earlier that we're going to have sort of more rain gauges across the area, and the budget to begin with was going to be a very sort of technical heavy project. But now we have, so I'm working on it 2 days a week. We have Eleanor who's working on it full time, and we also it's enabled us to ring fence money so community organisations can apply for funding. Because what was clear is that a lot of things that are going on in the town align with the Blue Heart project, and a lot of these people are really keen to get involved. So we've ring fenced money. So that we've already given out a chunk of money already this year, and these projects are now going. But just going back to my beginning point was that it's really helped build trust with the communities, but also the project partners. So those quotes at the beginning of that kind of fear of engagement, we're working with organisations that are traditionally very technocratic, and there hasn't been the budget or the capacity or the skills to enable real engagement. And I think what the Environment Agency is seeing now is that there are some brilliant bits of public engagement going on around the UK, but there's no kind of joined up thinking. There's no, it hasn't been mainstreamed. And so I think that's the real benefit of some of these DEFRA-funded projects, these EFCRIT projects, is that we can sort of mainstream some of the findings. But I'm just going to now give you a couple of quotes from the same cohort, after they were involved in this process, after they heard the community radio. So the first one is, if we are truly to make this work, we need not only information from the technical side of the model, but also from the actual people who unfortunately are living on the front situations or be close to flooding, who can actually tell us. And the second one, I was surprised by how many people coming back with detailed information to the project, feeding and stuff which could be very useful to us in the future. So there's been real light bulb moments that has just been just incredible. And it wasn't, I'd love to say that was the plan, but the main plan was to make sure we got the community voice in the project. But it's great that I've been able to, or we as a team have been able to kind of change mindsets. I've got two more slides that I just want to show. And this first one is just showing, it's from Cormac Russell, who is a big advocate of the asset-based community development. And it's all about studies versus stories. And studies, are really important. We need the data. Data is important. However, stories have real power. Now, I wrote the engagement strategy, and the main things that were in the community radio show was in that strategy, and I shared that with all the project partners. But it wasn't until they heard the stories of the people, that it changed people's perceptions and the importance of the community. And so, although studies are important, publications are important, stories are really powerful. And that links me onto my last slide, which is a quote from a paper from 2020. And it states that the split between natural and social science funding for climate change research has been roughly 95% to 5%. So you might be thinking, so what? Well, these numbers explain this imbalance between science and discovery mode, like all these papers telling us about the climate crisis, about, flooding predictions, about the biodiversity crisis, but we've got a problem because it's just things are not being delivered. And so I think we need to shift this balance quite considerably if we're going to, have real impact in some of the amazing work that is going on. Thank you.
Thank you, Kate. That was just so encouraging. Speaking as a ex-technocrat, I guess. A lot of what you said really resonated with me. I know the Environment Agency's approach to developing a flood management scheme would be DAD, which would be decide, announce, and defend, and then wonder why you had to redesign it because the locals didn't like it.
Yeah.
And that's exactly what you're talking about. We've probably got time for one question. If not, I'll ask it then, because if I may, I'm really excited by all this. It seems to me the biggest hurdle potentially is how do we sort of mainstream this with technocrats? How do we educate technocrats to actually relax a little bit and believe that communities can actually really inform in a really positive way what would otherwise be a more difficult scheme?
Yeah, so this is something that's I'm really fascinated by very recently since doing the Blue Heart project, and I think the engineers need to be brought on that journey. So we've got this example of the community radio, hearing the voices, but when we do public engagement events, it would be great, if the whole team comes along and meets some of the community and has some of those connections, and so you can build that trust. But ultimately, I think it has to be. I think community engagement is still seen as an add-on, and for it to be properly mainstreamed, then there has to be the budget and the capacity, and the space for everybody to work together. And I was actually having a chat with a couple of people outside earlier and talking about, the beauty of working in a team. You don't have to be the expert of everything. And that is why, I think it's really encouraging to see, interdisciplinary sort of projects and research and lots of different people coming together because everyone can bring something to the table, yeah.
And particularly, I like what you're talking about with trust, because that's in short supply at the moment with many big organisations, whether it's Environment Agency or water companies.
Yeah.
So, great,
cool.
Thank you. And the fifth and final presentation this afternoon is from Mehdi Khoury, Serious Gaming in the Circular Economy. Mehdi, welcome.
Well, hello. So let's take the serious gaming demonstration to the extreme. Let's just demonstrate it directly. See if it works real time. Or if it fails miserably, at least we will have tried, right? So let's give it a go. Is the browser on? That's pretty good. That's pretty good. Let's give it a go. The game is available. It's called the Next Gen Game. It's available online from pretty much anywhere. So if you want to find it, you search for Next Gen Water, and you'll find that one of the first link you find is the Next Gen project, EU project. And hopefully, if you go inside the output or results section, it's going to show you many things, what we've done, and also it's going to show you try out our game. So let's try it. I'm going to show you this one. We've developed several variants, several versions of the game with it. It's a serious game. That means that you're supposed to learn something when you play it. So, we were talking about.
Welcome to Toy Town.
Let me talk, please. So, we were talking about involving people, engaging people, and 2-3 years ago in Aquatech, it was shown by lots of the participants that engagement was one of the big problems in the domain of water. So we've been working, and we found one way to make people understand a lot about some of the water problems which are relevant in our imaginary toy town. So this is Toy Town. It's got around 300,000 inhabitants. There is a simulation engine that runs in the background, thanks to Barry's efforts. And what happens is all the components are linked to each other. So you got your reservoir alimented by rainfall, and then you got water that comes to the houses, the neighborhoods, the little monopoly houses that you see. It becomes wastewater. It's treated by your wastewater treatment plant, and then it ends up in the river. Sometimes it's treated, sometimes not. But lots of things can happen. So, for example, if I click on doubling my population, notice that at the moment you manage to meet 100% of your water demand. Your environmental flow, whatever is left in your river, is around 75%. So your fishes are relatively happy, not too comfortable, but quite happy. And we've got a bit of pollution. So we estimate pollution as some sort of cumulative depth of oxygen that happens in the river when you put nutrients in it. So let's say you double your population. From 300,000, you get 600,000 people. And then the system is on edge. Water is not an infinite resource. And when you show it to people, they realize, okay, you only meet 30% of your water demand, only 50% of your environmental flow is left in the river. So your fishes are getting thirsty and your pollution has shot up. So what can you do? And this is something where you can involve people. You can involve policymakers to understand the role of certain technologies, for example, or members of the public. So let's say you check in your neighborhood, what can you install to change what's happening? So what about we change the shower head? Perhaps something you haven't thought about. But if we implement one of these very fancy NASA shower heads that mix air and water, the fog shower system, so what would happen to our whole town if every house is that? So let's click on it. Oh, well, instead of just meeting 30% of your water demand, you meet 65%. Your environmental flow has gone up. Your pollution is not great. But let's see about energy. What's happening with energy? Well, if we get back to our normal situation, 2% of our energy footprint as far as water is concerned is coming from the wastewater treatment plant, and 98% is taken by the household. So if you've got economy of energy to make, you better make them on the household side. And installing just this shower head that we're talking about, at the moment we're consuming 1,200 gigawatt a year for the household in your town. If you install just this shower head thing, then you consume 800 gigawatt a year. So there's a huge cumulative difference in all these connected components in your system. Just changing one thing like that in every single house gives you a significant impact. Similarly, you can try different things. For example, there is a link to one of the presentations done before about the barrels. What if you have in every single household a rainwater harvesting system with a tank? So what will be the impact on the number of CSO events and your pollution, for example? So if we install that, I click on this, and here you're going to notice that first you meet a lot more of your water demand because obviously people can reuse some of this rainwater, but the pollution at the bottom has gone down from 40-something% to 14%. Why is that? Because there is a tank in every garden. Therefore, it absorbs some of the rainwater, and the wastewater treatment plant doesn't have to process this huge mountain of water in one go because we have these tanks which act as a dampener. And here we have a figure in the system. So without the rainwater harvesting, we have around 195 CSO events a year in average. With it, we got 160. And our pollution level are going down. What can we also add? Perhaps we can add other things, combinations of technologies, such as a sustainable drainage system. Let's put it on. Well, it seems that it works pretty well for pollution. Perhaps we can combine it in with them other things. So the list goes on. There's a lot of different technology one can try to combine with others, but the stuff that surprised us the most, or at least me, was material reuse, something which has not been explored that much by research as speaking about metals, because so far when we look about reusing material, we look about reusing nutrients in wastewater treatment. But if you reuse metals, they have a fabulous exergy, which is the amount of energy you have to spend to go mine the earth core to get the metal out, and then refine it, and then transport it, and all that. But these metals exist. They're concentrated by human activity, these heavy metals. And if you were to, for domestic wastewater, in the case of our baby 300,000 simulation town, if you were to recycle 85% of these metals, that would be in carbon sink equivalent, like covering 5% of the surface area of the Netherlands in forest every year. Now, this is just for domestic wastewater. Add to it industrial wastewater, which is 10 to 10,000 times more concentrated in metal, and you'd be doing the equivalent of covering 50% of the surface area of the Netherlands in forest every year, just for one town. So there's a huge potential to, well, save some things carbon emission wise. And there is no technology at the moment that really focus on extracting these metals out of wastewater. So yeah, this is a typical example of what this game has done, and hopefully variations of that will appear. I think somebody from the West Country River Trust has shown some interest for a version of that game that would focus more on the effect of farming downstream and this kind of thing. So thank you very much.
Thank you, Mehdi. I think that could become seriously addictive for probably everybody in the room and much more widely. We've got time for a question or two, unless you're all keen to go home and try this, which well, two people at least want to know more before they start clicking on it.
So are the outputs here based on real modeling?
Yeah,
or rough estimations?
We've taken some sort of catchment based on some existing rainfall simulated over 20 years. And then we have a real-time model that predict for the next 20 years what would happen to the different things, such as the CSO events and all that.
Yeah, and is it available on apps?
Yeah, it's working in real time using the successor of Python, if you want, Julia, the Julia programming language, which is like Python but much faster to work with.
Well, my question is pretty similar to the previous one, and just to make clear, what kind of mathematical connections there are between the different parts of the model?
Well, we got the expert here. Barry can give you a plethora of details, but we got a real-time model that gives us a system dynamic model, actually. And we have quite a fine granularity. Depending if we have a rainfall event, for example, we take every hour. But the days where there's no rainfall, we just take the whole day as a general data input.
Great, thank you very much, Mehdi. I think what you pointed out about metals recovery is really important, and there's a whole area there that's, I think, not well understood, and we need to think more about the circular economy with that. We'll move now into an interlude before we finally close, which is around sort of an open discussion of, well, where do we go from here? What do the next 25 years need to look like? And when we're invited back in 25 years' time for the 50th anniversary of CWS, what would we want to celebrate in terms of achievements over the next 2.5 decades? So Any observations or thoughts based upon what we've heard over the last 2 days and ideas that you've been inspired to consider? Shell shocked. Thinking about going home for the weekend. It's been a pretty full-on couple of days, and perhaps instead of asking you for some ideas, I'll just share some thoughts of mine and abuse chairman's privilege, because while everyone's been speaking over the last 2 days, I've been making some notes and recording little snippets of the discussions and presentations that really resonated with me, and my brain won't work like your brain, but there might be some things in here which certainly resonated with me and might give us some ideas to pause for thought as colleagues in the CWS plot out their course over the next 25 years or so. So a very personal perspective, and based on my experience in the UK and internationally. So that's the sort of context. And there are just three points that I want to make. And the first was inspired by something that Godfrey Walters said right at the beginning of the conference as a founder of CWS. He said, well, what is success? He didn't really define it, but Dragon gave us a clue when he talked about the mission of the centre, which is to operationalise sustainable water management. Not being quite clear what operationalise means, but he went on to say it's with the aim of solving real problems. And for me, that's a critical part of the ethos and purpose of the centre, which is it's about solving real problems and making a tangible difference in the world of water and the environment. And David went on to say in his bit, engagement with industry is essential to the success of the centre. And he had a lovely slide where it actually showed that industry is the main funder, but I don't equate income with success. What I equate with success is what does this mean in terms of outcome for the water sector, the environmental sector in the UK and internationally. And as we all know, problems globally with water are increasing, water scarcity, climate change, freshwater biodiversity in free fall, infrastructure crumbling. We could be here all afternoon and go through the list of those challenges. And practitioners like me and lots of other people are faced with trying to deal with those problems. And they need the whizzy ideas from the big brains within CWS to say, we could help you with this. But that also needs a close dialogue between colleagues in CWS and the practitioners, wherever they might be. And one thing, again, that's struck me, which is often under-regarded, was Andrew's comment around the fact that water companies are often reluctant to innovate, and often that's down to sort of fear of regulators and fear of failure. And I see one area where CWS can really help is in giving the industry, the water sector, the evidence to influence regulators and influence policymakers to say, we can do this and it'll make things better. We might fail occasionally along the way, but this is the right direction for a crucial part of human life on this planet. So innovation, engagement, and operationalizing for real problems. The second point I want to make, it came from a comment made by Seth as part of his inspirational journey from Uganda. And he said many things that really resonated with me, but the thing that in particular I liked was he said, diverse teams do better science than homogeneous teams. And a problem that probably we all face one way or another, we all have a pet interest, and we put our blinkers on and we charge ahead with that. But Fire said, quoting Leonardo da Vinci, realize that everything is connected to everything else. And Marianne, in her new career at Angela Ruskin University, said one of the highlights is an advantage is to work with multidisciplinary people. And the thing is to come out of our silos and recognise where those connections might lie. Because as water people, we just love to talk to other water people. But other people outside the water bubble are actually quite interesting. And recognising those connections is so important. And David made a point. We were just talking about the fact that planners are naive about water, but they're influential. You're absolutely right, because water infrastructure is by and large an urban phenomenon, but a pipe in the ground doesn't exist in isolation. It's there to serve a purpose, whether it's water or wastewater. And water people, we don't manage the urban environment, planners do, and architects, and ecologists, and a whole range of other disciplines. And if we don't engage in those, then we're pursuing literally a lonely furrow that's not going to go as far or fast as it needs to. And the urban space is increasingly important because in the UK, because of our regulatory and governance structure, we tend to forget that internationally, often it's municipalities which are driving water policy and practice and investment. So engaging with those different disciplines is so important. And also recognising that policy making, spare a thought for poor policymakers and legislators, is becoming a lot more challenging, with a lot more concern about the risk of unintended consequences. And that's where a multidisciplinary approach is just so important. And we tend to think about, well, it's all about the professions and so on, but Kate was talking about engagement with communities and people. And ultimately, we need to recognise that all of this is about people, and the quality of the people delivering all the stuff that we do is absolutely critical. And I'll just ask, if you look back over the last 10 years in the UK at all the serious pollution incidents that have resulted in multi-million-pound prosecutions, anyone like to hazard a guess what the main reason was for those failures? Any views? Why were all those dozens of multi-million-pound pollution incidents that killed innumerable numbers of fish? The answer is people. Almost, because I'm slightly nerdy in this regard, I've read all the judges summing up from those prosecutions, and every one of them talks about either incompetence, failure to follow systems and processes, or in some cases, downright illegal activity in order to falsify what's been going on. So it comes down to people. So, what I heard over the last couple of days is there's so much that we can actually do in our various professions to help people do their jobs better. And I was particularly struck with Albert's augmented reality, which looks like a much more efficient way of training and informing people, keeping them up to date, and helping colleagues, the practitioners, to do a better job. So engaging with people, working in a multidisciplinary basis, and then thinking about the people, and then use what it is that we come up with. And the final comment I wanted to make is based on Exeter and the Centre for Water Systems being the #1 university in the world for Sustainable Development Goal number 6. And in the UK, we tend not to think too much about the SDGs because we think we've got them all sorted. And internationally, I find that in Africa and Asia and Latin America, there's much more interest in the SDGs because they've got very often got further to go than we have in the UK and Europe. But when you look at SDG 6 in particular, two things are important. One is, and it's about ensuring the availability and sustainable management of water and sanitation for all. That Sustainable Development Goal underpins pretty much every other one of the Sustainable Development Goals. It underpins everything. Water is at the heart of everything. And the other thing that struck me is in the UK, we think we can tick that box. But when you actually go through the list of SDG objectives, we understand better the scale of the challenge we've got to face in a country like the UK. And then when you look up internationally, you'll see how much bigger the mountain is to climb that collectively we can help with. The first one that struck me was safe and affordable drinking water for all. Safe in the UK, not affordable. Up to 20% of our water company customers struggle with their water bills. It's a massive challenge. So how do we make water more affordable? And innovation can help us to deliver safe drinking water more cheaply, and that's where you guys come in. Improve water quality by reducing pollution, minimising release of hazardous chemicals, substantially increasing recycling and safe reuse of wastewater. I reckon we're about sort of 3 out of 10 in that in the UK. I'm probably being generous. Next, substantially increase water use efficiency and ensure sustainable withdrawals. 2 out of 10, maybe. Again, being charitable. Implement integrated water resource management at all levels. I'm not even going to hazard a number on that, but it's so critical and we're so poor at it. And finally, all those goals were by 2030, by the way, so we've still got time. But by 2020, we would have protected and restored water-related ecosystems. And you'll have seen the government announcement about abandoning nutrient neutrality. So that's out the window. So there is still a huge amount to do. And just looking down that little checklist of SDG objectives gives us some idea of what it is that we need to aim for. And Guang Tao, in his presentation, put up some slides on the sort of practical barriers and opportunities and said there's enough for the next 25 years. I reckon 25 years and a lot more besides. It's just up to you folk to think about what the priorities from that list and more besides might be, and how we're going to work on them. So I wish you luck in all that, and thank you for the opportunity to share these thoughts with you. Thank you. And now it's over to David and Savon to wrap up.
Thank you very much, Ian. That was a really great overview. Thank you. So everyone, I hope you've enjoyed the last couple of days. It's been good, isn't it? It's been fun, quite intensive, but good. And obviously, we really thought about how we were going to deliver these 2 days to you, and we came up with this idea of spending yesterday essentially looking backwards, and today essentially looking forwards. And in many ways, I think, as we look forward, I think we've reached a pretty important place in history, particularly when we're thinking about water. One might even call it a tipping point. I know that's got some technical meaning, but we seem to have got to a point in our history when water and water issues are becoming critical, not just something that would be good to have, but critical. And Ian has come up with his list effectively of issues. I could add some more, and you could as well. I mean, clearly global warming is probably number one, or as we now call it, or should call it, global boiling, because it's become so serious, and obviously its implications. Rapid population growth in many parts of the world, although interestingly, population decline in other parts of the world, causing serious water issues. Urbanization and the effects of urbanization. The aging infrastructure, we've been talking about that today, particularly in the West, in the industrialized nations, in immense issues. Pressures on water resources and water resource planning, or not water resource planning. Water pollution and its effects. You've got, we heard in one of the posters about microplastics. Never thought about microplastics, did we? 10 years ago, it was not on our agenda at all. Lifetime chemicals that will never biodegrade, whatever we do. We can't remove them from the environment once they're in the environment.
discharge of drug-resistant bacteria, all caused or at least mediated through our water systems. And something that's new and feels new to me, certainly we feel it here in the UK, is an ever more engaged and frankly angry public, angry with the way that we're managing our water and our water systems. So we are at a point in time where we need to do something. We need to step up to the plate, I think. And hopefully the things you've heard about today in the past 25 years and the next years, you'll see that we are stepping up to the plate, I think. And a bit like Ian, I sort of listened with a slightly different lens on, actually. My lens was, well, what has CWS done over the 25 years and what will it do over the next 25 years? What can we say? It's very biased because I can't disassociate myself from CWS, but I've tried to look back as if I were a listener and what I might have, what I thought or what I heard. And bullet points, what did I hear? Well, I was impressed with Godfrey's, and of course Godfrey and Dragon as well, in particular, their vision right back in 25 years. Was it a grand master plan? I suspect not, with all due respect. But it was a vision. It was a vision, and it was a strategy to go forward and do something. I think I would be and was impressed with the productivity of the centre, looking at some of those stats we've heard today. Not talking pounds and dollars, but just about the sheer volume and importance of the work that CWS has done. I think you must be impressed. I was impressed looking back again at the impact of the centre's research, academically, yes, but also industrially. And I think also impressive has been the centre's reach internationally. How many countries did we say it was? 150? 2, yes. That's impressive, isn't it, really, when you think about it? How, from a single research group in a single university in a single country has had that impact. And also the fact that the group has managed to stay, not in everything it does, but in much that it does, on the cutting edge. Or some people like to call it the bleeding edge, don't they, of technology. In other words, things that are going ahead and actually being part of that agenda, pushing that edge, that bleeding edge forward. I think it's come through quite strongly as well, the positive influence of the centre, whatever that means, has had on its staff and on its students over these 25 years. And I was really taken by the idea of CWS as a family, whether one was born into this family or adopted into this family. I think that's a nice picture. I think you've seen as well the breadth across the group, across the years, of the experience of people in the centre, talent, enthusiasm, and frankly, forward thinking, particularly today, I think, forward thinking. And a number of times I sat there listening to presentations about things I kind of knew was going on, but thinking, oh yeah, oh, that's interesting. I hadn't really thought about that. Great. I love to hear that sort of thing. I think you'll have heard as well, the centre is very, very, very keen on collaboration. And we want to collaborate and do collaborate nationally, internationally, academically, and with industry and commerce and government. And I hope you've been able to take in and to enjoy, frankly, hearing from research thinkers, research leaders, past researchers, present and future leaders as well. So they're just my personal biased reflections on what you've heard today and what in terms of the Centre for Water Systems. We would be very interested in hearing your personal reflections, if you have any. And if you did want to share any of your personal reflections about the day, please do so. Get in contact with us. It could be about the organisation, if the coffee was cold or whatever. You can tell us about that if you like. No, not that. the content. Have a think. Any ideas you might have for the future, any suggestions for future collaborations, we would be very, very interested to hear from you. So please do keep in touch. That's all I wanted to say at this point. So I'm going to hand over now to Slobodan just to wrap us up.
I've also written a few notes during this session. This is my Tesco shopping list at the back. So I'm really delighted with the outcome of this event. I think it was professionally or scientifically successful. It was very informative. Those of us who work here, I suppose David's and my job as directors of the center is to be on top of everything, or at least to know what's happening, which is pretty much impossible because there is so much going on and new people and new projects are starting every few months. I suppose it was, of course, informative for people who are not or who were not members of the center to see what we are working on at the moment or what we've been working in the past. Young members were able to learn about the history of the center and perhaps, hopefully, become more proud of being part of it. So that's all great. We all learned something at this event. I'm very confident that the Center for Water Systems will continue to grow. And I have 4 reasons for that. The first one is the engineering department has what we call a business case undergoing a process of internal approval, an element of which is that the Center for Water Systems, or as they like to call it, the water group, will grow. In other words, will hopefully get funding to employ a few more academics and professional services staff and so on. That's the first reason. The second reason is I'm fairly certain that we will continue to be able to get new research grants. And the third reason, as one of those grants, we are very hopeful that we will be able to get funding to run yet another center for doctoral training over the next 5 years and another 5 to finish it off. So some of you, external partners are already involved in helping us with that in different ways. If we do get it, we will approach others to get placements for our students and so on. And perhaps the fourth reason, which makes me confident that we will continue to grow and be successful, is really this event, because it went on so well. And speaking of which, when we have the team wash-up meeting in a couple of weeks to analyze if the coffee was cold or at the right temperature, I'm going to propose that we do this every 5 years, if anything, because it's nice. So in 5 years, some other people from, I don't know, Australia or Sweden or wherever they come from will be able to come. So why not? If we wait for another 25 years, I probably won't be around. And anyway, why not? That's my thinking about that. Obviously, I need to say a number of thank yous. So first of all, big thank you to all those of you who need to go get on a plane or a train, pack your pajamas and, take a long trip, in particular Cobus. He disappeared. There you are. Very good. So that's really, really appreciated. Then I need to thank, of course, all the presenters for making the effort to prepare and deliver their really nice talks, for chairpersons for expertly to the minute sticking with the schedule. Well done for that. And Nia Owen and Debbie Ford, I can't see them around. Well, you will see them on your way out. They did the with the whole golden hands, they contributed to smooth running or preparation of this event. So they will appreciate if on the way out you say hello to them, and also give them back this thing. That will slightly marginally reduce the costs of this event for us, and will make us look a bit more sustainable. So that's that. Or again, on the way out, there will be another coffee at the right temperature, and I believe some cakes and desserts as well. So if you're not in a hurry to catch a train, stay for another half an hour or as long as you wish, and let's have a bit more chat. And finally, have a great weekend. The weather in Devon will be wonderful if you're staying. Either way, have a safe journey home. And on that note, a few seconds before, proudly, before 4:30, it's my pleasure to declare this event